Good morning, everybody. Welcome to class this morning. As we get started today, I have just a couple of announcements for you. One is that I have gone back and I have graded your module for assignments, so you have grades in there for those items. If you want to go and have a look at that feedback, by and large, very well done, as per usual, for what I've seen turned in. So thank you all for that. Your Module 5 assignments will be due on this coming Sunday. Your Module 6 assignments will be due on the Sunday after that. But then you get to take a little week off. And maybe you'll take a week off or maybe you won't. Because the next thing that's due after that is your midterm exam. So essentially you can look at it that way. Your midterm exam will be due roughly, like October 14th or something like that. Trying to do the math here, struggling. Probably it's more like, probably more like October 17th. Your midterm exam will be due. Check the begin here for that, but that's the next thing after Module 6 that you have due. So you have a little bit of rest and a little bit of break there. And just to prepare you now, we won't be doing any live streams during those 2 weeks. During the week of the midterm, I'll have a little drop-in time set aside just for you all to drop in and ask questions about the midterm if you have any questions about the midterm. But it's pretty straightforward. We'll talk more about it next week before your fall break week off. So, all the hard work that you've done up front here, it's going to pay off and get you a good little rest here in a couple weeks. Just, stick with me for a couple more weeks and you can have you a nice little break. But we're talking about common support problems today. And just like everything else that we kind of discussed throughout the semester, we are looking at these in more general terms, right? Our common support problems. I mean, we do look at them through the lens of our information technology discipline. But really, a lot of what we talk about when we talk about common support problems and supporting these common support problems could be applied to other things. This is probably one of the more specific modules that we do, more specifically related to IT. The connections to other things are a bit more stretched here. But nonetheless, the idea of being able to identify common support problems and have an understanding that they're coming to you is pretty important, right? Like, it's one of the things that we kind of need to consider. That whatever role that you're in, there is a set of common problems that you're going to encounter most often. And having an understanding of these types of problems, not even necessarily these specific problems, is going to help you in the long run, right? So if we take a look at a list of our common support problems, we can break them down in different areas. We see hardware problems, we see software problems, we see network problems, we see user problems. Now, this user problems here, that's going to be basically your largest area for support tasks, especially as a tier 1 support agent, right? The biggest number of problems are going to fall in that user problems category. Security problems, documentation problems, vendor problems, and facility and operating environment problems. And so when we look at our problems broken down like this, we can see these different areas or these different spheres in which, support issues will arise. And some of the things that we see here might be pretty obvious. Like, of course, hardware problems are incredibly obvious, right? Like if you have a hard drive die, that's a hardware problem. And that's something that has a definite solution. But when we look into some of these other problems, like our facilities and operating environment problems, that's a place where our problem-solving techniques need to be employed just a little bit more, right? We have to be a little more creative because when we're working in a facility, that facility is predetermined, right? So in this predeterminate facility, if we have a problem with the structure or how it's laid out, we don't necessarily always have the option of just demolishing it and building something new, right? Sometimes we have to figure out a creative way to work within our current operating environment in order to be able to solve these problems. But we'll take and we'll have a look at several of these throughout our class session today. We'll break them down. I'll try not to go too deep into them just because it does get a little redundant, a little repetitive when we break down these problems into their sub-problem sectors. So we'll try to keep this light, and we might even wrap up just a little bit early today, just because this is the kind of stuff that you encounter in a lot of your other classes here, right? These common user problems. You encounter a lot of the hardware problems and a lot of the software problems in the hardware software classes that you're taking here, and you learn how to fix those things, right? So this is more of just a general awareness of these spheres and how we can kind of interact with these different types of problems and categorize problems to drive ourselves towards solutions, right? And so the first one is hardware problems, and we can break hardware problems down into subsections, right? Hardware installation problems, hardware compatibility problems, hardware configuration problems, and just simply hardware malfunctions. Right, and believe it or not, your hardware malfunctions happen less often than you might think, right? It's more often an installation or compatibility problem that is rearing up here, or a configuration problem that causes your hardware problems. Right, on occasion you'll have something that dies or just stops working, and then you can just do a repair on that. You just do a fix on that by replacing it. But in general, more of the bigger issues come from installation, compatibility, and configuration problems. Obviously, hardware installation problems are instances when we are installing new hardware, right? And when we're talking about installing new hardware here, we're talking about installing new hardware from a couple different perspectives. Right? Like we can look at it from like the perspective that we're used to thinking about it, right? Like we've taken new RAM and we're putting it into a computer, or we're taking, just some new part in general and putting it into some device, right? And the problems that could result as that, right? Like maybe we didn't seat the video card or the RAM or whatever all the way. Maybe we put it in the wrong slot. Maybe we whatever. But we can also think about this from the perspective of larger systems, right? Like servers and computing devices and how they go into a network. Right? Because when we think about our network, a network is really a part of an ecosystem, right? Everything on a network is part of an ecosystem, and that network is your ecosystem. And so the way that traffic can flow through that network, or the way that a device could work on that network, could be impacted by how certain hardware is installed. And when we talk about installation and configuration and compatibility in that regard, that's where you start to see a whole lot more issues. Like, the majority of your networking classes are all about how we configure these hardware devices to be able to operate on a network. And so that's really where we start to see these numbers of hardware installation, compatibility, and configuration problems rise immensely. Hardware malfunctions are fewer these days, right? Especially as we're moving away from more mechanical parts into more solid state kind of components, right? Like that's the big difference between our standard hard drive and our solid state drive, right? Is that our standard hard drive has moving pieces. And when you have moving pieces create friction. And friction causes wear and tear on the moving pieces. So that's why we see oftentimes these hard drives breaking down over time, simply because of all of the moving, causing heat, causing friction, which results in a breakdown of the material. Now, some solid state drives aren't very great, right? Like, build quality on them is not awesome. They burn out, they die. But if you get a nice one, like if you get a nice like M2, solid state drive, and you have that in a machine, like that's going to last a long time. Because there is none of that friction. There's none of that heat being generated by motion, right? So you don't have parts grinding against one another. So, especially as we advance these technologies and as we improve the technologies that we put into them, these solid state components that we're dealing with are gonna last longer. Right? So I could see a perceivable future where, with a completely solid state device, where the computer could last, barring any installation compatibility or configuration problems, a long time, just based on what's in there. I mean, when you see something like a Raspberry Pi, for example, or an Arduino, and you see those put into production, and you see how long they can stay just running continuously, completing commands and such, like that's the kind of thing that I think we're looking at for the future of computing devices in general, is just something that can be up and running at full capacity, 24 hours a day, 7 days a week, no wear, no tear. Everything's all good. So there's all sorts of stuff that you can examine there, right, when it comes to hardware problems. And when we look at our hardware problems, and when we look at them in relation to what we're doing now versus what the issues were several years ago, right, we see fewer hardware problems and fewer hardware configuration problems and fewer hardware compatibility problems because of plug-and-play standards, right? Like our plug-and-play standards are a huge deal, right? And this isn't mandated by anyone. Like, when we look in other industries, like if we look in, say, web development, right, and you see, like the W3C, the World Wide Web Consortium, kind of being the overseer of HTML and all that sort of stuff. There's no real governing body here that is looking over our plug-and-play standards, right? This was just some protocols that the industry agreed upon. They looked at the state of computing as it was, and they said, you know what, we need to standardize things. Especially prior to these plug-and-play protocols, which were, in the 90s, we see these coming around. Like, you had to buy specific devices for specific machines. I mean, I even remember, back in the early home computing days, where if you were trying to buy a mouse, you had to make sure that mouse worked with a Mac versus working with a PC, right? But nowadays, you can buy a singular USB mouse, and it can work on any device because of these plug-and-play standards, right? USB standards came out of these plug-and-play standards. These are just agreed upon standards, right? Like, businesses just got together. They said it's going to be more cost efficient. It's going to be more effective. It's going to be better for the end user if we come up with some protocol that we put into place industry-wide. So we see things like Bluetooth, and we see things like USB, and we see things like SATA, right, being standardized across different computers, across different devices. So it's not just, well, you got this device, so you have to buy this part, versus, well, you got this device, So you have to buy some other part. So we get these communication methods. Like one of the things that we have to deal with is the communication methods that our operating system uses to recognize and incorporate hardware components. All right, because you remember that this operating system is essentially just the conductor that is managing the orchestra between your software and your hardware, and ensuring your hardware works together. So having standardized communication protocols that allow all these pieces of hardware to work together via your operating system is a huge deal. I mean, nowadays we don't have to worry about going out and finding specific drivers. Like, we have these protocols in place where standard off-the-shelf drivers can work with any device, right? Like, when was the last time you plugged in a new mouse and had to go out and find a special driver for it? It's probably been, if you even remember that at all, it's been years and years. Now, these automatic drivers that we see that are installed whenever you plug in a new device, they'll get your device working, but they might not necessarily allow you to take maximum advantage of all the new hardware's capabilities. So that's the case where you'd need to go out and get a special driver and download it and install it so you can take advantage of all the capabilities there. But just for basic functionality, for the thing that the majority of people need, you can just plug it in and go, and that's why we call it plug and play. Right? So, yeah, our hardware malfunctions, they account for a small percentage of hardware problems, and we can actually reduce the amount of hardware malfunctions that we see by doing a burn-in test. And I think, just taking a moment and talking about a burn-in test here is important for us to kind of look at, because this is something that you do in industry, just to make sure everything's working before you put something in production. Like, I've seen it a bunch of times where, you go to a data center and they have a separate staging room where they can, as they're approaching putting new hardware into production, they can take it into the staging room, they can stage it in an isolated environment, and then they can run a burn-in test on it. Run it for 48, 72 hours, run it for a week, run it for 2 weeks, however long their protocols demand that they do that, just to see if any components fail. Because if hardware malfunctions, it's likely for the hardware to malfunction early. Right? Especially when we're dealing with solid state type of components. Because those malfunctions are more than likely the result of a manufacturing defect. So if we immediately took these things and we put them out into production, and they had some kind of manufacturing defect and they failed, that could result in downtime, in data loss, in loss of, and as a result, loss of money, right? So we take these things and we stage them in a staging area before we put them into production. We, run this burn-in test. We put them under a full load for 48 hours, 72 hours, a week, however long. And if something's going to fail, it's going to fail during that burn-in test. That way we can find out if there's a problem right then. And if there is a problem, we can fix it without anything adversely impacting production. And if there isn't a problem that comes to light after the burn-in test, they can easily just put it out into production and have some confidence that it will work, right? Which is great. So that is something to consider. Similarly, we can look at software problems here, and we can see a lot of the same sort of thing here, right? We see installation problems. We see compatibility problems. We see configuration problems, right? Those things kind of carry over from our hardware problems, right? Like, installation, compatibility, and configuration are big things. And those same type of things apply here. You know, was it installed correctly? Right? Like that can be a huge deal for some things. Like we don't have to worry about that as much anymore. Right? Because nowadays with installers, they just kind of take care of a lot of installation and compatibility problems for us. But definitely there was a time where this was more prevalent, and it even still is prevalent to a degree, right? Like you want to make sure you're installing the right server software onto a server so that it'll be compatible with what you want it to do and configurable and all that kind of stuff. What we see more often nowadays are issues with software performance and software bugs, right? And that's more of our big issues in addition to configuration problems here. Like configuration, again, right, is going to be your big deal. You know, how this software is configured. Like if you have a soft firewall on your computer and you configure it to block all traffic and then nothing works, right? Like that's one of those configuration problems that we're talking about there. But software bugs also are a big problem because those are just errors in coding. And so as a result, what we see here is we see vendors having to fix bugs. Right? So you might end up, if you end up in some kind of development role or supporting some kind of development role, having an understanding of how software bugs are fixed in production is important, right? You know, we see these bug fixes and upgrades to software to help performance, to help, improve performance and to help, stop these bugs from causing issue. And if you've ever wondered about the term bug, it actually came from an actual bug, right? When we look at the idea of a software bug, like if we go back in time, Grace Hopper was a naval officer for the U.S. Navy, worked in their computing division. So Grace was on a ship. A moth flew into a relay computer. We're talking about mechanical parts here. So the moth flies in, gets in between some of the mechanical parts. The computer can't run. And so now we have this computer bug, right? We have an actual bug. And there's actually a picture that you can find online where they removed the moth from the machine and taped it into the logbook. So you can actually see the first computer bug. And so that's where we have this idea, that's where this term bugs came from. Right? And it's typically just an error in programming. And when these errors in programming are fixed, or when we upgrade software and update software, we put out different releases. And in putting out different releases, we do versioning. Like here we have a patch. That's just a replacement for just one or a few modules in the software that fixes some bugs. Right? So like I could break down like how exactly this works. Like when we're building software, we build software in multiple modules. Right? There are multiple files that we put different functions into. This one file has some specific purposes. This other file has some specific purposes. And they all work together for the purpose of running the software. Right, so if there's just a bug that's happening because of a little issue in one or two of these modules, you can put out a patch that just fixes that bug. And that is just what we call a patch. We'll see on the next screen a little more about version numbering and how we denote a patch in our version numbering. When we update, we're repairing several known bugs in a previous version and creating and releasing an update. Right, so we might send multiple patches to fix bugs as we find them, or we might have multiple bugs that we've got to figure it out and fixed, and put that all out as an update. And as you know, like a lot of updates now are done via automatic updates. Right? When we look at version numbering, we see version numbering like this, right? We see our first release version. That's the number before our decimal point here. So for example, 2.0 here, that's the second full release of this product. It's the second new version of this product. Oftentimes you start out with 1.0, then you go to 2.0, 3.0, so on and so forth. If you update it, if you release an update that just changes several bugs, right? You're not changing any features. Then you add a 1 or a 2, you add whatever update release is after that decimal point. Right? So when we're talking about that first release, we're essentially talking about a feature release. Right? Like I've got a bunch of features that I'm going to put into my program. That's going to be, and then I'm going to release it to the public, and that's going to be version 1. When it comes to version 2, I'm going to have a bunch of new features in there, I'm going to have changed a bunch of things to make them nicer or whatever. And that's version 2. When we're looking at these .1 update releases, we're not talking about generally massive feature updates, right? We're just talking about fixes. Maybe minor feature updates that squash certain bugs. But we see, several new features, but a lot of times a lot of bug fixes here. When we add another 1, after this, so we're not saying here that this is the 11th update release. We're saying we've had 1 update release and 1 bug fix. Now, that could alternately be written as we see here, right, with our letter, like 2.1a. That way we can, kind of make it more clear that this is not the 11th update release. It is the first bug fix release on the first update release of the second version. Right? Another way we could write this is with another dot, so it would be 2.1.1 to make that even more clear. And then our service pack is when we take an updated version and we take all these other updated releases and bug fixes and just package them all together and put that out as kind of a new version. So it's not a completely new version, right? Like we don't have a bunch of new features or a bunch of things being overhauled or stuff like that. But we do have the minor features that have been released via the updates, the bug fixes, all this kind of stuff. And we can take those over a period of time that we've released gradually for the current owners of the version of the software, package them together and put that out with the software going forward, and we call that a service pack. And something that we kind of looked at here is when we're talking about network problems, right? Let's move on to network problems now. Our network problems are a combination of our hardware problems and our software problems, and that's probably kind of become clear to you as we've been discussing this stuff. Because, when you look at it from the perspective of your networking hardware, right? Like we see software configuration issues, we see hardware configuration issues, hardware compatibility, hardware malfunctions, software compatibility, all this sort of stuff comes together into this network, because this network really is an ecosystem. Right? And all of these different softwares that are running on the network and all of these different hardwares that are running on the network, they're all a part of that ecosystem, and they could all cause issues. Like the example that we have here is bottlenecking, right? We could have network monitoring software that detects network bottlenecking, and that bottlenecking could be caused by a certain piece of software that's on the network that's like making calls to another something or other that's, restricting traffic because it's more or less, sending a bunch of traffic in this one direction. So it makes things harder to get in and out, that sort of thing. Almost like it's DDoSing something, right? So that bottleneck is being created. But when that bottleneck is being created, even if it's created by something that's software, that has an impact on the hardware, because it's going to cause the rest of your hardware to slow down, stop processing things as fast, so on and so forth. Let's take a few minutes and sit with user problems. Right, we'll sit with user problems here for a few minutes and then we'll wrap up just a little bit early today. But we see essentially 5 subcategories of user problems here. And these are mistakes, misunderstandings, wrong products, inadequate training or failure to read documentation, and forgotten information. Now, as we're approaching these user problems, I want you all to notice something here. Right, like all of these things are a part of human nature. Right, like we talk about quick start behavior there, like the failure to read documentation is a result of quick start behavior. And quick start behavior is like this natural inclination that we have as human beings, right? Like we all just want to, we don't want to waste our time, quote unquote, reading the manual. We want to get in and get our problem solved. So we're just going to jump right in and try to do it. Right. And then we end up 3 hours later with, a set of IKEA furniture that does not look anything like that picture that's on the box. And when we use terms like mistakes and misunderstandings and wrong products and forgotten information, I want you to kind of note the language that we're using here, right? Like these are words that don't imply intent, right? And we can't look at our users from that perspective, that they intend to cause problems. Like nobody's maliciously going out and messing up their systems, right? Like when we put this into a frame of reference with the stuff that we've talked about earlier in the semester, people need these devices. They need them to do work. They need them to make money. They need them to communicate. They need them to relax. They have a need here. So when we're putting these user problems in perspective, we have to understand that these user problems aren't intentional problems. It's a mistake. It's a misunderstanding. They got the wrong thing. They weren't properly trained, or they just simply forgot. And these are all human nature things that we're dealing with here. And the first thing that we have here is just a mistake. And this is a large part of common support problems. Like how many times have you been trying to maybe enter your password and maybe your finger grazed another key, right? And you just accidentally put in the wrong password. Right? Or maybe you thought you were logging into one system when you were logging into another system, and you're like, this password should work. This password should work. And all of a sudden you're locked out, right? These inadvertent keystrokes, these misclicks, right, can cause us a lot of issues. They're not intentional, and even us, right, as people who would consider themselves to be more technologically advanced, maybe than some of our other user bases. We make mistakes as well. And the big solution here is a well-designed system, right? Like when we talk about design, like when I talk about web design with my web design students, one of the things that we talk about is anticipating mistakes and giving users an opportunity to correct their mistakes. So we're going to use testing to try to make sure that we figure out where mistakes could happen. Right now, we couldn't possibly figure out every mistake that somebody could get into, right? Like, that's one of the common jokes and common tropes of, dealing with quality assurance people. Right? They'll find a way to try to use it in something that you never imagined to break it, right? So that is there, and you want to use alerts to possible errors in order to give your user the opportunity to correct themselves. Right? A mistake shouldn't permanently cripple somebody's account or system or whatever, right? Like, they should be able to correct the mistake and move on. And if we design computer systems in that way, we'll end up seeing fewer tier 1 help desk tickets opened because they have that capability. Misunderstandings is the next one. And this is where maybe you think or you think you understand about certain product features or the limitation of certain products, but you don't. Right? And like my example here, I really like that. Like, how many people have you walked in to their room or their office or whatever, and you've just seen thousands of files just on the top level of their desktop folder? That's going to make things hard to find. That's going to make things difficult on them. And in that instance, it could just be, well, they didn't understand the role of the subfolders, or they don't know how to create and use subfolders to help organize their data. They think it's good enough, and it's just a misunderstanding, right? Like, this and a lot of these things are when education plays a solid role. Right? If we're educating our users in addition to helping them, we also see issues like this start to decrease. Right? So this is one of the places where we start to talk about the importance of the role of education in help desk and tech support and computer training. Right? Like, education of our users, especially going forward, is critical. Because if our users aren't educated, we end up in this same spot over and over and over again, which is something we'd probably not deal with. Now, we might have to deal with it from several different users, but at least that one user has a better understanding of what's going on and may not have that issue again. Wrong products. Users might purchase or install the wrong product to accomplish a task. And I mean, this has happened to me before. Like, you get a piece of software, you do maybe a little bit of research into it to think like, oh, this might solve my problem. And then you install it and it doesn't solve your problem. Right? And this is where a big thing here is just education. Again, as the subject matter expert, you as the support agent should have an understanding or should be able to figure out, which is why we, do some of the assignments that we do where, I have you research different softwares and make suggestions based on what you find. You should be able to gain an understanding of what these individuals need so that you can help them pick the right products. That's something that you're going to be asked to do a lot in a support role or in a computer training role, is to provide your input on products. What products should be used, what products shouldn't be used. Because, in that regard, you are the subject matter expert, right? You are the tech person. And I know it happens here a lot, where a lot of the individuals at different levels of support are consulted about different products before things are put into production. So understanding the capabilities and limitations of a piece of software, or at very least being able to research and figure things out, and knowing how we can move in an alternative direction if that doesn't quite meet expectations, is important. The next thing that we have is our inadequate training or failure to read the documentation. We have a lot of problems that occur just because somebody's not been trained. Right? If they don't know how to do it, how can we expect them to know how to do it? You've probably experienced that on your own job, right? Like wherever you're working now. That's a common thing, to just kind of thrust new employees into a role and not give them all the training that they need to survive, if you will. And so that could lead to feelings of inadequacy, that could lead to stress, that could lead to, a lot of bad feelings on the part of our users when they haven't been trained and they have these certain expectations put on them to be able to use this device, or for this device to function in the way that they need to. So, again, education is at the core of this. Failure to read documentation. We mentioned quick start behavior before. Right? And quick start behavior is a psychological phenomenon that is found in ourselves as human beings. Right? It's just this tendency to skip the installation manual and try to get this new hardware or new software component installed and operational as quickly as possible. Right? Because we want the new thing. We want the new thing. So anything that stands in our way as a barrier to getting the new thing is meaningless, right? We want to get that new thing. And I've got that sentence there, and it's probably something that you've heard a bunch of times. You might have even said this. Oh, if I have any problems, then I'll read the manual. Or I'll read the manual later if I run into any issues. Right? But just having a quick read over that manual first is important. And this kind of gets into, some of your behaviors that you should be engaging in as a support agent, as someone who's doing, this sort of role. Right? You have to kind of break yourself of this quick start behavior because you know that your users will probably do it. So for you, instead of just jumping straight into it, take time and read the manual. That way, not only will you have a better understanding of what's going on, but you'll have a better understanding of how to explain it. With this quick start behavior, it ultimately just translates into wasted effort and lost productivity. Because the longer you spend trying to figure something out that's not working, right, especially something that could have easily been resolved by just reading the manual and learning everything up front, then the longer you're losing money because you're not being productive. Now, the next one here is the cause for the number one most gotten help desk ticket, right? This is the top tier, highest number of help desk tickets you will get as a tier 1 support agent. Drum roll, please. It is forgotten information, where the user just forgets. You ever forget? It's happened to me. Usernames, passwords, PIN numbers, operating procedures, just how we're supposed to do something. Right? Because the user might even be trained, but you get trained into something. This is something that happens here a lot, right? You get trained in a technology, but then you only use that technology 2-3 times a year. Right? So you get trained in it now, you're good at it now, and then 6 months later when you need to use it again, well, you've forgotten everything. Forgotten passwords are the majority of the things people go to the help desk for, is to get them to reset their password. And again, we want to be clear that this is human nature. People forget. And it's going to be frustrating to us as tech support agents to encounter all these forgetful people. However, in doing so, I think we have to be clear that these things happen. Again, we shouldn't make our users feel inadequate. We shouldn't make our users feel less than. And maybe educating our users to do some things to help them remember. Like we have here, a tip is to write down a reminder of their password. Right? Not necessarily write down the password themselves, but if you write down a reminder of your password, then if somebody, sees it, they have to crack a code and, figure things out before they can get it. But if you just have a reminder of a password written down, then that could be the thing that somebody needs to remember their password and to, lessen the amount of these forgotten information requests that they would have of the help desk. So again, education. Education. Education is at the core of it all. Let me just have a quick look here over the rest of the stuff. I think everything else is pretty well explanatory, and you'll get a good explanation of it in your textbook as you go through this week. So just as to not prolong this, we'll just go ahead and wrap things up here. So if you have any questions as you're watching this later, feel free to email me. Feel free to contact me via Teams. If you're watching this live with me right now, I'm going to hang out in the chat for a couple minutes, just in case anybody who's here with me live has any questions. Remember that the next module is due, coming up on Sunday. So you'll want to make sure you get that done. Make it through this week, make it through next week. Then we can kind of relax for a little while there. But that's all that I have for you for today. Thank you for watching, and we'll see you next time.